Hello my friends, welcome again to my video channel. Today we will start a new project, a new summer project. I hope it's also a small project. Oscilloscope Hameg HM605. A member of our local amateur radio club gave it to me and he said I should check it, it does not work. Funny waves on it. Okay, whatever funny waves are. I said okay, bring it to me, we will check it. And we will see. First some words, small introduction to this scope. This scope has a bandwidth of 60 MHz, dual channel, alternate chop, time base, all standard features. Channels can be selected, one channel can be inverted, AC/DC grounding position, trigger level, slope, mode, calibrator, component tester. It's a simple component tester, it's not a curve tracer, it's not calibrated, it's only a component tester. We will see later how it works. Here we have a special feature of this scope. It's a delay for the time base. It's not a second delayed time base, it's only a delay. That means the main time base, or if there's only one time base, can be delayed by a certain time in the range between 0.1 microsecond and 100 milliseconds. This is a 10 gear pod to select the point where the delay starts, and then it can be delayed, and when the screen or the beam is delayed from a certain position, we can reduce or increase the resolution. So we have a sort of delayed time base, but again it's only one time base and not two. Well, let's fire it up and see what happens. 1, 2, 3. No smoke, no big bang. There is something. I have no input signal, ground. Can be shifted up and down. I think that's what the old man said to me. Now I'm in a higher speed, deflection speed, but it is very slow. Not nice. Totally nonsense. XY mode. This is the Y position. The X position does not work. I think there should be X. When this is Y. Now is it this? Okay. This should be used, but again, this is a Lissajous figure with a signal which does not exist or shouldn't exist. All these effects are a strong indication that we have a problem with the power supply. The component tester, very artificial. Nice. Where's the wire? When I short it to ground, then it's vertical, that's okay. Current, voltage. But this figure, the Lissajous figure, shouldn't be there. Funny. Very funny. This is an indication again that something is wrong with the power supply internally. Maybe tried out electrolytic caps or any other problems. Bad rectifiers. That's it. That's what the owner told. He is right. But focus does work. Obviously intensity works. That's good. Good sign. The CRT is obviously okay. Some illumination. Can be switched on and off. That's also working. Well, let's have a look into it, and we have to open the case. There are two screws on the rear side. Then we remove it. Okay, power cable can also be removed. Then we should be able to remove the cover plane. Oh, what is this? Defect BF199 T902 out of HM605. Surprise, surprise. Someone was looking for a fault. He identified the fault. Did you repair it? Why is a bad one in there? Let's collect it. And now we can flip out the whole chassis. Oh, dust, everywhere is dust. Here we have the typical Hameg design and construction. It is solid, not exciting, not top notch, not top quality. It's a good quality. Construction is okay. Here we have the power supply, 5 rectifiers. This is in line with the schematic we have here. Voltage is 110 volt, 55, plus 12, minus 12, plus 5 volt DC and 12 volt AC. I assume it's for the heater of the CRT. Should be checked, of course. The other side, some dirt, someone was in there. Okay, here we have a problem. This axis here can be taken out, and this pot does not move. This it is stuck. That's the reason why this knob slipped out. We cannot move it. When I fix the screw, then the plastic will break. So first I have to loosen this pot to clean it. Well, I've seen one thing. You can see it. This electrolytic cap shouldn't be there. I'm sure the manufacturer didn't intend to have a cap there, because this cap is in parallel to one of the caps we have here for the rectifier circuit. Maybe someone found that the cap has lost capacity and he installed an electrolytic on the other side, on the bottom side of the board, of the layout of the board, but this is not a good practice. When a capacitor has lost capacity, it has to be removed, because there's a danger when it is still in circuit. It could happen that the capacitor produces a short over the years. I will check with capacities, but first I will check all voltages. This additional electrolytic cap which is installed here, we have seen, I checked it, it's in parallel with the second rectifier. And the second rectifier is the BR2503. Sorry, BR2500. This one. And this BR2500, whereas the schematic is this one. And the capacitor is C2500. Here's the number of the rectifier, the number of the electrolytic cap. And the cap is, where is it located? (2500), this one. It is 220 microfarad, 100 volt. and this one have the same. So this new one is in parallel with this one. This means this capacitor has lost its capacity. Well, not a good practice. By the way, you see the damage here on this electrolytic. The size is wrong, it's too high. When it slips out of the chassis, then the chassis rubs over the electrolytic cap and causes damage. Also has to be swapped. And the other ones, well, my scope is ready, so I will check the voltages regarding voltage and ripple. The scope is set to 2 volt per division, considering the probe 10 by 1. First I check the plus 5 volt. Oops. It's nearly okay. And the input voltage. Yes, I have to reduce the sensitivity. Now I have 5 volt per division. The input, there's some ripple, but it is in the tolerance. This is 10 volt and 5 volt is here, so we have sufficient overhead between the lowest voltage. That's okay, plus 5 volt. This is plus 12 volt, the output voltage. I have 5 volt per division, and this is the input. Yes, the minimum voltage is above 15 volt, 16 volt or so. That's also okay. The ripple is acceptable. This is minus 12 volt. Sorry, this one. Minus 12, it's okay. And the input voltage is a little bit weird. It's a positive voltage regulator in inverse mode. I will show it to you what I mean. That's minus 12 volt. This is sorry. I'll show you what I mean. This is the positive voltage regulator. The positive output is grounded. This is minus. And here we have the little bit weird ripple, which is not related to this to ground. So we have here a strange measurement, but the size effect is minus 12 volt is also okay. Now checking the positive 55 volt. We have 20 volt per division. 20, 40, it's nearly 60. Okay, a little bit high, but no ripple, no problem. It is okay. Maybe it should be readjusted. But that's not the topic in the moment. And now checking the 100 volt DC, this connection, and we see we have 50 volt per division, so we have 120 volt, also a little bit higher than specified. The 50 volt was also a little bit higher. Maybe the adjustment is not correct, but in general it's okay, no ripple on it. So as I see, all voltages are okay and no ripple on it. I'm a little bit surprised, except this capacitor here has to be taken out. It's not so easy. Now I see why the guy didn't do it, because it's not so easy to get access to it. The whole board is rather difficult to unsolder. There's all these transistors have to be removed. But it cannot be in place. But in the moment, this is not the topic. The problem is anywhere else. We have seen that the power supply is okay. This cannot be the reason for the problems we have. So my next step will be the time base. We have seen that the time base does not react as it is expected. Even with no input signal, we always have some weird behavior in the horizontal, in the vertical also, but I have to start anywhere, so I will start with the time base. Here is the time base. That's the board for the time base. and then we can look for some checkpoints. I was just looking for some checkpoints in the time base, and the time base switch is of course one of the candidates to give a checkpoint. And then I saw this. These contacts are bended and they are touching each other. There are two levels of a switch, and here are the other two levels. And when I compare it with the original schematic and the layout, I see here the wire, and this is one row of contacts. Here's another wire, here's another row. Here the same, one wire, a row, one wire, a row, but they may not touch each other. They are isolated. They don't look isolated. I will bend them and see what happens. And when I was bending them back, I've seen that some of the pins are broken. This is a rail, and the rail should have contact to each pin, but this pin is, as I see, broken. And another one also. And here it does not look better. Hey, what happened? I can imagine someone touched it, didn't see what he is touching. Let's here I see it's not broken now, but I have to resolder it. The whole rail here, these rails have to be resoldered. But I will check it now whether it's a little bit better. I'm driving from one crazy thing into the other, to another crazy thing. The time base now works. It's half a second per division. The literature figure is not okay. There is still some problem. The speed increases, and I can, no, okay. Maybe it's a 50 Hertz signal, so it's higher. Seems there's still a problem. In general it works, but do you see what I see? Of course you see it. Wrong polarity. From right to left, it should move from left to right. And there's another problem. The X position knob is also inverted. When I rotate it to the right side, the beam should also move to the right side, but when I rotate it to the right side, then the beam is on the left side, and when I rotate it to the left side, the beam is on the right side. So someone swapped I think the connections of the plates of the output of the X amplifier. This is a crazy scope. Mystery, mystery. We are on the rear side of the cathode ray tube. No fear, I checked the voltages, discharged it, so there is no danger. And I gave it a long time, and even the plate voltage disappeared. By the way, the plate voltage has a separate connection, it's not here. Pin 7 and 8, it's the X output from the time base. We have it here. The guy noted it. This indeed goes to 7, but that's wrong. So I swap 7 and 8. 8 is loose. Now I will look for 7. Oops. Okay, I swapped these pins, and now we have the picture as expected, from left to right. That's okay. When I go to component tester mode, we see that the X position now, when I rotate it to the left, the picture goes to the left or to the right as it should be. Same with this deflection, fully left. When I go to this position, fully right. Okay, and this is the center position. Well, we still have the problem with the Lissajous figure. Seems there is an AC coupling. I assume it's 50 Hertz or so. What should it be else? If there's internal circuit which operates with 50 Hertz in the X and Y mode, it's a component tester. And maybe we have a problem that the component tester, even when it is switched off, couples into the X and Y amplification. Could be the reason for the problem. I will check it. Before I continue with the search for the problem in the X and Y amplification, I will solve the problem with this pot. We have seen it was stuck, and the coupler, which is between the pot and this axis here, is broken indeed. As you see, two halves. Shouldn't be too difficult to get a new one. Is a standard 4mm axis on both sides, so such couplers are on the market. I will buy a new one for this purpose, but this pot is still stuck. I let it soak with some oil, and it's a icing spray. I think it's from the automotive range. I think it's a good solution for this pot. And now I will wait overnight whether the oil is effective. This pot is now turning freely as it should. I ordered a new coupler. I use one in metal version from the model craft industry or business. They have rather good equipment, gears and other things which we can also use in the electronics. I hope it's not too big. It's a 4mm axis. Hope it fits. If not, I will swap it with another one and take then this new coupler in another place. I also ordered a set of new electrolytics. I will swap all of these electrolytics. This is obviously dead. This is heavily damaged on the top. You see the other three. But now I will focus on the main problem we have. There's still some hum in the picture, and I have an idea. We have here an output. The scope has here three outputs. One is the X output, the so-called sawtooth. One is set modulation, and the other one is the Y output, the vertical output. And I will have a look whether these two signals, sawtooth and Y output, are here with or without any hum. This could be an important indication where to look in the schematic. I have an input signal of 1 kHz from a signal generator, sine wave, 1 millisecond per division, and we see we have here a strong superimposed oscillation, whatever it is. When I switch off the input signal, we still have something. The sawtooth is, as I see, okay. The hold off time is a little bit long. I can increase it with this pot. Maybe there is some realignment needed, but that's not the topic in the moment. The oscillation is a little bit weird. I connect the scope to the other output, to the Y output. What is it? Same problem as we see. Let's have a look to the other channel. Go to channel 2, switch over to channel 2, triggering also channel 2. Same problem. When I switch off the input signal, there is still an oscillation. Can I measure the frequency? Where is trigger level? oh, it's 10 nanosecond per division. There is something oscillating. Self-oscillation, 5 nanosecond per division. We have a frequency of approximately 200 megahertz. 5 nanosecond, yes, 200 megahertz. When I switch to the other, same problem. As it looks, it's not a problem of hum. It's a problem of an oscillation in the, yes, channel 1 and 2 is identical, could be the final. I switch over to channel dual mode, invert one channel. More oscillation, hurrah, hurrah. We have progress. But in general we see there is something not okay. It's obviously a problem in the vertical amplifier. Now going to locate the source of this oscillation. Again, we have this channel here, it's a yellow one, the lower trace where the scope is triggered. That's a Y output, and here I use my the blue line, the blue trace with this loop, and then I move the loop all over the circuit. This is the 2 channel inputs. I see nothing. This is a delay line. Okay, here is something, the delay line, but the most impressive oscillation is here in this region. And this is the final stage of the Y amplifier, the vertical amplifier. These are the power transistors here. And when I touch, look into it, and here's the CRT. Okay, so it can be assumed that the problem is the vertical amplifier, the final amplifier, and this oscillation is then distributed all over the whole scope, so I can measure it at different points. The delay line, of course, is connected here to the black one. You can see that we show it, that we flip it around, and this is the end of the delay line. And this is the beginning of the delay line. We have a similar result. So I think the oscillation is generated here in the vertical amplifier and fed back via the delay line into the rest of the circuit. And then it is distributed also here to the Y output. This is a part of the X board. It's fed to the trigger circuit, and where the vertical signal is fed from, which is shown here. And here the same picture again. This is a vertical amplifier with the power transistors. This is the delay line coming in. But the most impressive oscillation is here in this region, especially here. So I strongly assume we have to look now for the source here in this region. Maybe a bad frequency compensation, a little bit overcompensated, although we will see. A different position of the scope, that's the amplifier vertical output. I see a lot of signs of tampering. Whatever happened here? A ground connection, a screw, a long wire. This is a wire to the CRT, a loop. And see what happens. Have a look at the scope. When I touch this, bend it out. Suddenly we have a big oscillation. When I bend it back, the oscillation stops. This solder connection here looks not original, looks very bad. It is made with a bad soldering iron. It's a very big blob. The soldering iron is good, to solder gutters or so, but not an electronic circuit. I have to take it out, shorten this wire. I don't think that this is original solution, such a long wire. I can't imagine, because such a loop is always dangerous, and we have here an oscillation. It's a long inductivity and a long capacitive load, especially a capacitive load. Here is a resistor in the back. There should be a resistor in series to the CRT plates, vertical plates. That's okay, but this long loop here is not okay. And here I see some reflections. Or what is it inside? Doesn't look good. Anyhow, I have to take out this board and check what's going on. The vertical final output is now out, and we see here a lot of mess. Whatever happened, ugly. This ground connection here was soldered a little bit. I could remove it simply using this ceramic screwdriver and pinching it off. I put it on, move it away, bing, and it was loose. This wire is definitely not original. The output connection is this pin here. Here we have the, yes, it is marked on this side. Here is one plate connected, and the other plate is, I think, connected here. This pin, these wires here, these two blue wires are not original. They are much too long, I think. You can see it here on this side. This one here is a heat shrink over it, not used. This other one has a plastic. I have to look whether the resistor is in. I will remove these two wires, clean the board, look for any problems, shorts or interruptions, and rewire it as it should be, and look for a solid ground connection. And then I'm quite sure that we have the problem of the oscillation solved. But this mess here cannot work. Cannot work now. Oh no! Oh no! Now we are at the end of part 1 of the videos about the Hameg HM605. We have seen that some surprises are involved, and maybe further surprises are waiting. My impression is that this scope was badly treated in the past by one or several guys with the golden screwdriver. And I've seen further details. Anyhow, stay tuned, stay healthy. See you on this channel.